Okay, so today we're going to talk about the mole ratio. So the mole ratio is the ratio of the coefficients in a balanced chemical equation. So in this case we have Nr, and then Ng. Okay, so this is for the number of moles of the required substance. Okay, and there's the coefficient of the required substance, and then the number of moles of the given substance, hence the G, and then the coefficient of the given substance. So it is called the ratio because it communicates proportion. Whether it is 8 dozen to 4 dozen, 600 to 300, or 4 moles to 2 moles, there will always be double the number of silver atoms per units of silver sulfide. So mole ratios are very useful because they can be used to solve problems, like the following. So in this example, it says determine the amount of silver required to make 0.876 moles of silver sulfide. So the question gives us the number of moles of silver sulfide, okay, which is 0.876 moles. That's given in the question, and it is asking you for the number of moles of silver. That's what we're trying to find out. So we need to first determine the mole ratio. Okay, so we're going to determine the mole ratio. So to do that, we need a balanced chemical equation. Let me write that out in a different color here. So a balanced chemical equation. Okay, so it says here, determine the amount of silver required to make so much silver sulfide. The balanced chemical equation is actually given to us, and it looks like this. And we'll always have at least the basics of our chemical equation provided for us. Okay, we may have to balance it out, but in this case, there we go. So we need to do our mole ratio. Okay, our mole ratio is, so what is required, in this case, Ag over what we're given. So we're given Ag2S. Okay, so this is the coefficient. All over the coefficient of our silver sulfide, which is equal to 4 over 2. So now we need to calculate the number of moles of silver required. Well, we're going to take that and we're going to say that this is technically equal to the number of moles of silver over the number of moles of silver sulfide, which we know is 0.876 moles. Okay, so we're going to isolate this variable, which means I need to times by this to cancel it out. So it looks something like this. Let me move that out of the way. It will look like the number of moles of silver is equal to 4 over 2 times 0.876 moles. And if I'm to do that, I get an answer of 1.75 moles. So we need to note that when no coefficient is written, the coefficient is always assumed to be 1. Since the ratio can be stated a number of different ways, it is convenient to place the required substance in the numerator. Alright, so here we go. In the example problem that we just did, the solution was prepared in 2 steps. The first step was to determine the mole ratio for the 2 chemicals in the reaction, but many students do not need to record this step because they're just able to do this mentally. It just cuts the length of the solution in half. So if you think of a balanced chemical reaction like a recipe, you might be better able to do this step in your head. So here we have the ingredients for homemade lemonade as provided to us by the Alberta Education. So it says in this recipe for homemade iced tea, what is the ratio of tea bags to lemons? And then what is the ratio of granulated sugar to lemon juice? If you immediately said 24 tea bags to 4 lemons and 600 milliliters of sugar to 60 milliliters of lemon juice, then you may want to start answering the next practice questions by simply stating the ratio. As before, we need to keep the calculation straightforward, so we need to continue to set up the mole ratio with the required substance in the numerator. So here's our second question. It says when aluminum metal is exposed to air, the metal reacts with oxygen in the air to form aluminum oxide. And there's our formula, as provided to us, all nicely balanced and everything. So it says if you react 6.25 moles of aluminum with a sufficient amount of oxygen, determine how many moles of aluminum oxide will be formed. B says to determine the number of moles of oxygen required to react with the 6.25 moles of aluminum. Well, so for A here, we are given the number of moles of aluminum being 6.25 moles. And it's asking us for the number of moles of aluminum oxide. Okay? So if we set this up, it's, again, our required over our given. So our required is Al2O3 all over the number of moles that I'm given, which I'm given the number of moles of aluminum, is equal to the coefficient of Al2O3 all over the coefficient, EF, the coefficient of the number of moles of aluminum. So that means the number of 2O3 all over the number of moles of aluminum, which I know is 6.25 moles, will equal, if I look up here, I'm given aluminum, I'm required to find Al2O3, so this becomes 2 over 4. Okay, so to get this out, I must times it by 6.25 moles. Cancel out, times by 6.25 moles, and I will get a total of 3.13 moles, saying that there will be 3.13 moles of aluminum oxide formed. So in the second part here, for B, it says here, so B, it's asking how much oxygen is needed. So again, I know aluminum is 6.25. The number of oxygen required, that's what I don't know. So I set up the same sort of ratio, but in this time I'm talking about the amount of oxygen, but I'm still using the aluminum, that's what I'm given. So coefficient of oxygen over the coefficient of aluminum. Okay, so that means the number of moles of oxygen all over, we know this is 6.25 moles, given in our question, is going to be equal to, in this case we're dealing with now oxygen and aluminum, so it becomes 3 over 4. I need to times by 6.25 moles in order to isolate the number of moles of oxygen that I'm looking for. So times by 6.25 moles. and I should get an answer of 4.69 moles. And in fact, the reaction will require 4.69 moles of oxygen. If you have any questions about that, we are going to be dealing with it next day. So thanks so very much for paying attention.